All right, guys. So good evening once again. And last class we were looking at integers, and I did a little illustration with the number line to give you the idea of how we add and subtract integers. All right. Now, if you can recall, for those of you who have been here from the beginning, you would have known the various types of numbers that we have in our number system. And just to see who may be somewhat revising or looking over or checking the website to read up on the notes, let me see if there's anybody who remember the different types of number that we have in the number system. And I'm just going to call randomly on persons. So I'm going to start. Let me call on Miss Wisom. Miss Wisom.
Yes, sir.
Remind us of the different types of numbers in the number system. What are they?
Whole numbers, rational numbers. You mean the ones from last class, sir?
The number system in general. So you start.
Oh, like odd numbers and then something there?
No, well, the ones that we had gone through so far.
Oh, so, well, so you mean like whole numbers, integers, rational numbers. No man, we never do odd number. Counting numbers, natural or counting numbers. What next one? Yeah, no, just those who got you, sir.
All right, so
counting numbers, whole number, integers, and rational
numbers, whole number,
and real numbers, yeah.
Integers,
yeah.
Rational, irrational.
Yeah.
A set of all of these numbers make up the real number system. And we also mentioned there is a complex number.
Complex numbers, yes, sir.
You won't be dealing with at your level. Now, all of these numbers are the different types of numbers in the number system. Now you have other subgroups, as you would have mentioned, odd numbers and so on. You have other subgroup of numbers, but when you talk about the main type of numbers that make up the number system, we are really referring to the ones that we just gone through. Is that clear to everyone? All right, now, having learned the different types of numbers and having also learned about operations, and we saw that we have some basic operations that we generally carry out in math. Can anybody, I'm going to call on somebody else this time, remind us of the basic operations that we carry out in maths. And I'm going to ask Ms. Scott this time to tell us the basic operation that we use. And I'm looking for all the operations that we would use in the BEDMAS mnemonics. Go ahead, Ms. Scott. Are you there, Ms. Scott? Are you with us? I'm not hearing you at all, Ms. Scott. Are you, if you are saying something, I'm not hearing you, could you just probably type something in the chat so that I understand what is happening with you on your mic? All right, so in the meantime, while we're trying to get Ms. Scott to respond, I'm going to call on Ms. Cummings. Ms. Cummings, would you like to answer the same question that I asked Ms. Scott?
Yes, sir. You have brackets, exponents, or power, division, multiplication, addition, and subtraction.
All right, good. Now, can you tell us what are the main purpose of operation? What are they for? Ms. Cummins, you want to answer that question? Ms. Scott, is there something wrong with your, or you just decide to be silent? You can type in the chat. Go ahead, Ms. Cummins.
Sir, they give us instruction onto what to do with a math problem.
Or
Like how to,
with the numbers. Because remember, we said that mathematics is about the study of numbers and quantities, and the operations now tell us what to do to the quantity when we are calculating. Because if you see the plus sign, you know you're to add, or you see the subtraction or the multiplication or division sign. Those tell you what to do with the numbers, right? And so we call them operation because you're performing operations when you're carrying out these instructions. All right, now we are doing 4 basic operations on these numbers. We are adding them, subtracting them, multiplying them, and dividing them. Those are the 4 basic operations. But from time to time, we'll also have work with brackets, and we also work with powers, right? So those will be also added to the operation that we'll be using. And in terms of the order of these operations, the sequence in which we should carry them out, Mr. Ojeno, would you like to tell us what the order of the operation should be? Are you there, Mr. Ojeno? Are you hearing us?
Yes, sir, I'm hearing you. What was the question again?
So I was asking, you know, if we are to do a combination of operations, what order we generally carry out these operations in order to get your answer correct?
Okay, first you would have bracket. Then you have power. Then you do the division, then multiplication, then addition, and last subtraction.
All right. So yes, that is the order in which we generally will carry out the operation in order to get our answer correct. Now, just to let you know, addition and subtraction, they're both on the same level. So you can do one or the other at that same point, right? So if you're following the same sequence, so we do brackets, then we do powers, then we do division, or multiplication can be done at the same time. So both of them, you can actually do both of them at the same time because they're at the same level. Division and multiplication can be done at the same time. But you have to do those first before you do addition and subtraction. And addition and subtraction can actually be done at the same time too as well. Hold up your hand, guys, if you understand clearly what I just said.
Sir, can you repeat, please?
So in terms of carrying out the operations, the sequence or the order in which you should carry them out is based on the mnemonics BEDMAS. So you work out brackets, then powers, then you can do division. The order is general division, multiplication, then addition and subtraction. But when you get to division, you can choose to do both division and multiplication at the same time at that point. You just want to know that you make sure you do division and multiplication before you do addition and subtraction. So you have to give those precedent over addition and subtraction. So make sure you do those first before you do addition and subtraction. But both division and multiplication, whichever one you choose to do first at that point, it doesn't matter. When you're doing addition and subtraction, whichever one you choose to do first, it really doesn't matter because you can do either of each at that same time. Is that clear now?
Yes, sir.
Okay. All right. And as we get into the maths, you will see examples that we're looking at. Now, we would have looked at all these numbers in the number system. And so I am starting off with integers to show how we can apply the 4 basic operations to integers. So we are going to look at how to add them, subtract them, multiply them, and divide them. Now, it so happened that when we're adding and subtracting integers, there are some rules that we have to follow. And so in the previous class, we were looking at the rules. So I'm just going to go and recap now what they are. So first and foremost, can somebody tell me what are integers? Scott, you want to tell us, is your mic working? What are integers, Ms. Scott? And for this topic, these will be our objectives. So we should be able to define integers. We should be able to add and subtract integers by using the rules of directed numbers. Now, we should also be able to multiply and divide integers using the same rules from directed numbers. Now, you must understand that the term directed numbers also means integers. So to say directed number, we are just using that as a different name for integers. So what are integers? Anybody? Ms. Waysam, tell us what integers are.
Positive or negative numbers are including 0, or as you would say, whole numbers with negative numbers.
Okay, very good. So here we have integers are numbers which have either a plus or minus sign attached to them, such as +7 or -5. Now, usually when we were working with numbers from primary school, we never usually specify that we have a sign attached to them. We either say we're adding or we are subtracting. Now, generally when we're adding, we usually add whole numbers. Now we would add, and remember what whole numbers are. Whole numbers are numbers, the natural numbers, which are the numbers that we use to count. So that means 1, 2, 3, 4, those are what? Natural numbers, or we call them counted numbers. So if you have all the natural numbers and you include 0 with them, now you get the set of whole numbers. So the set of whole number includes 0 as well as natural numbers. So that is what completes the set of whole number. Now with whole numbers, you generally would have positive numbers. So in primary school, most of the operation that you carry out, you generally work with positive numbers. So if you're subtracting, you generally take away a small positive from a large positive. And so the idea was pretty much clear. But when we reach in a little bit more advanced stage now, by saying positive and negative numbers, we're really carrying out the same principles that we were dealing with in primary school. But now what we may do is we may be looking at adding the two numbers. So adding positive and negative numbers really still obey some of the rules as when we were working with whole numbers. Now, there's a little bit more extension to the rule. So we want to know, bear in mind the idea behind positive and negative number. Now, why you think we come up with these numbers, positive and negative number? Anybody? Why did we come up with positive and negative number? Now, one of the things that we do in science is that we generally measure the temperature of things. Now, we know that for liquids, especially water, if we should heat it up, it will heat up to a point and then it turns into steam. So we call that point where water turns into steam, we call that 100 degrees Celsius. Now, we also notice that if we should cool down water and make it colder and colder, it changes into ice at a certain temperature. So for those reference points, they would call the freezing point of water 0 degrees, right? And the point at which it turns steam, we call it 100 degrees. Now, we also know that if you continue to take heat out of the ice, we notice that the temperature can get even colder than 0. So to account for colder temperature than 0, now we start using negative values. So we might say -1 degree below or -2 degrees below 0. And so now that would account for even colder temperature than 0. All right. Now, so that is one way the positive and negative number will help us when we're dealing with temperature, right? And two, you can think of temperature in terms of molecules. If you have hot molecules, if you call those positive, and if you have cool molecules, we could call those negative. But if you mix molecules that have the same temperature, so if you mix a hot and a cool molecule having the same temperature, then what would you expect the temperature, the final temperature would be? Anybody?
Repeat, sir, if you have what?
Let's say that you have some molecules. Let's say you have 7 molecules of air, hot air, and we call those hot air positive. And now we have some cool air, 7 molecules again, and we call those negative. And suppose we mix them together, what would be your final temperature?
Cool, sir. Let me go. Cool air.
But let's add some value to it. So we have 7 molecules that are cool, we call them -7. And then we have 7 molecules that are hot, we call them +7. If we are to add these 2 sets of molecules together, what would be the answer? So, Adriana?
0, sir.
Sound like you're guessing. Is it guessing you're guessing or you're telling me?
I would say 0.
Oh, you sound not sure of yourself now. All right. Yes, the answer would be 0 because we would consider that the hot molecule and the cold molecule kind of cancel out each other. And if for people who have hot and cold water at home, you would realize that if you want the temperature of the water to cool, if you want to have a certain temperature of the water, you can mix the hot and cold water together. And depending on how hot you want it, you would probably put more hot water than cold one. And if you put more cold water than hot water, it's going to get colder. So it is these two extremes that will give rise to these ideas of positive and negative number. Another situation where we can think of positive and negative number, and as I would have mentioned, when you're dealing with money. Now, if you have some money in the bank, right, then whatever money you have in the bank is yours. But let's say that you have your ATM card and every minute you go to the ATM machine and you keep drawing, taking money from the bank and not putting back any in, then at some point you're going to have $0 in the bank, right? Now, sometimes, depending on what kind of account you have with the bank, sometimes the bank can allow you to take money after you have $0. They'll still allow you to take money from their account, right? So in that case, now you're taking money that is not yours. You're taking money that now belong to the bank or some other person. And so those money that don't belong to you, you can think of those as negative money. So the positive money is what you have for yourself. When you don't have any money, you have $0. But when you're borrowing people money now, you're going to owe them. So it has to be a negative money because you always have to be paying back to people what you owe, or else you're going to have problems, right? So if you think of positive and negative in that way, you will realize that it can apply to that situation of when you have money and when you owe money, right? And it's an easy way to understand how to calculate them, right? And so we're going to just think about some scenarios, and then now we'll get the ideas behind the rules. Now, from previous class, I was illustrating some things on the number line. And those illustrations was to really show you what happened when you add two positive numbers together, what happened when you add two negative numbers together, and what really happened when you add a positive and a negative number together. Now, this number line indicates that if you're moving from to the right, you're moving in the positive direction. You're moving to the left, you're going in the negative direction. And that's why they call these numbers directed numbers, because positive give you the direction to the right, negative give you the direction to the left. And negative just means that you're reducing the amount. So you could start at, say, 6, and you reduce by 1, you get to 5. You reduce by another one, you get to 4, and 3, and so on. And if you keep reducing, by the time you get to 0, and you keep reducing by 1, now you get to -1, then -2, and so on. That means you could start at -3 too as well, and if you keep reducing, then you get -4. So as long as you're going in the direction of left and you're reducing down that side, you get less and less, right? Now,